Now we are moving to the panel discussion sessions. I would like to invite all the speakers first, Professor Hatziargyriou and Professor Mancarella and Dr. Laverty to join me first, and also I'd like to invite our audience the questions from the audience about any questions you like to ask for about the any special questions you would like to ask any of the speakers, and either post your message here at the chat or raise your hand. So now I've got Mahanas Anvari. He's raising his hands. Would you maybe have a question? Would you speak now, or?
I think that the best is to write the question in the chat. It's now open for everyone, so please put your questions there.
Okay, excellent. Yeah, thanks, Petros. Now, probably I'd like to ask a couple of questions. First, questions to kickstart the conversation. Maybe I'd like to ask all the speakers, our distinguished speakers, about the challenges. What are the challenges for the microgrids, and also the next steps? Obviously, you know, you all have a lot of experiences you have shared today, and also through your publications. You know, we have seen a lot of work you've done. So maybe can we start first from Nikos? Hello. Right. Okay. So maybe how about your thoughts, Pierluigi, about the challenges and also the next step for microgrid?
Yeah, no, with pleasure. Thanks. Nikos is back, so maybe.
Okay, Nikos.
Okay, I would say that microgrids, the important feature that distinguishes microgrids from normal distribution lines with distributed generation is that they appear to the upstream network as a coordinated unit. So the control of all these different units in different time scales with the different power electronics presents challenges that are solved and improved continuously. So I would say that providing more efficient control as technology develops is what still is not solved and still needs to be worked at all levels. But now we have also the tertiary level, where you can think of various multi-microgrid systems, where different microgrids collaborate with each other to provide the overall optimal solution to the more wider distribution area. So I think that's an area that still needs to be discussed. I wouldn't say that economics is a very basic problem, because of course it depends on how you see microgrids. You have to compare them with larger systems, and when you speak about parts of the distribution network where it's already generation installed, the difference is the control, and this is what really is what makes it microgrid. So this control infrastructure is not really something very expensive. So for me, the technical issue is still quite important.
Well, thanks very much, Nikos. Yeah, indeed, the control, you know, is certainly a challenge, and also in terms of economics. Maybe Pierluigi, you have some thoughts. Could you share your thoughts, please?
Yeah, sure. So to add to what Nikos just said, I think if we really want to go for widespread applications, it's important to understand to identify where the most suitable initial cases would be. And I think, for example, in Australia, there start being clear cases of microgrids where, as Nico was saying, economically actually they will make sense because, for example, they are at the end of long feeders with low reliability level. Maybe in areas where there are extreme events like bushfires and all that. So the economics seems to make sense, but in other areas a little bit less, and we need to develop specific business cases and perhaps change the business model approach for that. So there is a role that the regulator may play, and I think the more we understand that the economics per se would work, but maybe an issue of developing the right business model, with time, I think this aspect will become more and more important. And of course, then we will have to resolve all the technology issues. But again, I think that with more and more microgrids being implemented, also technology issues will be resolved in a faster way.
Well, thanks very much, Pierluigi. I certainly agree. The role of a regulator it becomes more important in terms of it's one of the barriers as well for broad deployment of the microgrids and the right business models. So So can I maybe invite David, do you have some comments and share your thoughts about the challenges and the next step for microgrid?
Yes, certainly. So the whole topic of microgrids obviously has been kicking around for the better part of 20 years at this stage. And I guess one of the first problems, again, is something a little bit of a frustration in terms of definitions and how it's described in literature, in that even the question has come up in the chat here. Do we mean are microgrids on grid or off grid? What really do we mean by the microgrid? And ultimately, I guess it doesn't really matter. We just need to be clear in our own work what we're trying to describe. One way or another, microgrids do offer fantastic possibilities, but it's reliant on this whole aspect of the smart grid and communication systems emerging to actually enable these technologies. Like take case in point, vehicle to grid. We understand now that from literature, it's very clear that vehicle to grid offers fantastic possibilities. But where are the technologies to do this? Where are the equipment vendors or the vehicle vendors producing the technologies to actually enable vehicle to grid at the device level? Where is then the communication system which allows the system operator to command and control such devices? So I guess in a way we're in this kind of valley of death of technological readiness level, in that from an academic point of view, I guess we've taken it as far as we can go. We've demonstrated that this technology works. There's still some interesting academic challenges for us to work on, absolutely. But those ones that I regard as essentially solved, the challenge now is to push through this valley of death and to get some actual large-scale deployments of this out there and start generating some empirical data. I think that's the challenge, and I don't think I'm expert enough to say on how we bridge that valley of death issue. There's a lot of good books out there of people who've been around this mill a lot, but certainly something has to be done to push through this.
Well, thanks very much, David, for sharing your thoughts. Yeah, indeed, and that pretty much echoes well with both Nikos and Pierluigi on probably on the regulator and policy and the economic side as well. So we have an our audience colleagues here posted a number of questions here. Can I read out? The first questions from Hatziargyriou about how to differentiate between reliability and the resilience. So probably that question goes to Pierluigi, isn't it? How to differentiate between reliability and the resilience. So from Hatziargyriou.
Yeah, I'm happy to take it. Well, I'll just there are different ways of looking at that. There are lots of discussions ongoing, including in a SIGO working group. C447 has been working quite some time on definitions and differentiations between the two terms. To cut it short, I would say that if you imagine a reliability is associated with sort of normal, credible events, and resilience is associated with non-credible events, particularly what we call effectively high impact, low probability, particularly linked to extreme weather, earthquakes, these kind of things, where that's in those cases we actually talk about resilience. So very high impact flooding events, landslides, and all these kind of things that I briefly showed in my presentation, those effectively got to do with resilience. Whereas the fact that a transformer can fail, a generator can fail, that these are quite ordinary faults, I would say that's associated with reliability. This is very high level. There are different ways of looking at that, but I think if you go with this, you're not too wrong.
Thanks very much, Pierluigi, for explaining. Now we got a question and from Alamjir Hussein from Australia. Probably the questions as goes to all the speakers. Can we build a 100% renewable energy? So maybe Nico, how about your answer about build 100% renewable energy?
Well, as you know, this is already targets set by different countries. Also in Europe, they are talking about 250. The system will be fully carbon free. So also all energy system, including transport, and including thermal heating, cooling, etc. So, of course, these are plans, these are visions. But I would say that at a smaller level, it has appeared that you can operate systems, microgrids, with 100% renewables. For instance, the Kythnos microgrid, which is one of the first microgrids in an isolated system, does run with 100% renewables. Of course, it needs storage for that. It needs techniques for controlling frequency and voltage based purely on power electronics. But technically, it is possible. At least at the micro level, this has been proven at the island level.
Yeah. I think yes, I fully agree. You know, this technically is achievable in terms of probably you need to upgrade the facilities, particularly storage systems. Pierluigi, what do you think about your thoughts? Is this achievable in Australia or Melbourne? 100% renewable energy.
Yeah, of course, it is achievable. I completely agree with Nikos. I mean, I think at the moment, obviously the economics is still not there, but probably in a few years it will be. You require a significant amount of storage of different types. But while this may be more challenging, for example, for the UK, where there is not much potential for pumped hydro. For example, in Australia, this is not the case, and therefore even aspects like deep storage, like energy storage, like the power storage, like batteries, become less important. In some areas, the issue of inertia may be a problem, but again, if there is hydro, pumped hydro, and all that. These are still synchronous generators, so there is not even potentially a problem of low inertia conditions. Although again, lots of new technologies, including grid forming, converter-based technologies like batteries and all that, somehow are proving to be very, very effective, even in the absence of inertia. In some conditions, there are challenges associated with system strength, so effective voltage stability and converter stability. But again, there are ways of fixing it. For example, by using synchronous condensers. This is really like easy. If you don't know how to read and how to write in power system, just put a synchronous condenser and you fix the problem. But I'm sure technology will catch up soon. So I really don't see ways why engineers cannot do it. Just give us enough money, basically.
Well, thanks very much for such very positive reflections. How about David in Ireland? Because obviously Ireland is one of the countries that pioneered these low carbon energy systems. How about you? What do you think, David?
Well, yes, no, absolutely. I agree with the sentiment that this is definitely possible to achieve 100% renewable energy in the power system. But obviously, if we were trying to design such a system, we wouldn't start with the systems that we have inherited. So the big technical challenge is how do we address the legacy of the infrastructure we have, and of course the question of system inertia is obviously extremely important for how we do the transition and how we carry on operating an AC system. It's just kind of frustrating that with our modern technology, with power electronic converters, and with the vast majority of electrical loads now being interfaced through power electronics, really the old attributes that were important, such as system frequency and whatnot, remain important for operating the system, but the loads don't really care anymore. So there's an interesting quirk in that regard. One thing that, if I could just make a comment that would be very useful in literature, I see this all too often, that in literature people speak about the system frequency being an important measure of the balance between supply and demand. Please don't forget that system frequency is the control signal which regulates supply and demand. It's all too common in literature to see that confusion. But again, the question is, if we're moving to a 100% renewable grid, is frequency an important attribute anymore in terms of supply and demand? Maybe not. Maybe we're going to do that balancing through an alternative communication channel, not using frequency as the communication channel anymore. Lots of possibilities, but of course the transition is not going to be easy and it will be expensive, but you have to weigh it up about what is the expense of not doing anything about it in terms of the climate catastrophe that will be upon us if we don't do something about it.
Well, thanks very much, and glad to hear all of these optimistic views from our speakers. Certainly, they open up a lot of research questions in terms and technologically and also economically as well, and policy side as well. So now our next question is from Mahanas Anwari. His questions probably goes to direct to Pierluigi about the what you mean. You mentioned the mini grids. What do you mean the off? Do you mean off or grid or on grid? And what is the difference when we want to find the least cost mini grids? So that's the question from Mahanas.
Yeah, thanks for the question. I think on this, I would very much agree with David. What David was mentioning earlier, it doesn't eventually really matter as long as we define exactly what it is. And in this respect, it can be both. in the sense that if you take a general concept of mini grids or microgrid as an aggregation of distributed energy resources, and then you go with that, then effectively it can be grid connected or not grid connected. Now, the former definition that historically we've been given to microgrids is this is aggregation of DER that can actually go islanded. So if formally, if it's grid connected and this aggregate cannot go islanded, this will not be called a microgrid. This is the formal definition has been given also in SIGRE committees and in previous projects, including with Nikos. However, in the last years, I'd say that now we generally call microgrids any kind of aggregation that is connected to the grid, even if actually cannot become islanded. So at this point, then looking at the economics of this, if you are grid connected, whether you can go islanded or not, your economics really is played with the grid. For example, the possibility of using flexibility to actively interact with the rest of the system. For example, providing grid services and all that, and therefore accruing revenues by doing that, playing different markets and all that. Well, that is certainly direction to pursue to improve the economics of the mini grid. The moment that you are completely off grid, for example, you are isolated and you are developing some kind of, for example, low carbon system in an isolated area and all that, obviously the economics there is all about the cost of the resources and how you trade off between investment in the resources and the reliability level that you want to achieve. You may invest into more resources, more storage, and all that will cost more, of course, but then you will achieve higher reliability level. And of course, the opposite, with less investment, you may have to accept a reduced level of reliability.
Well, thanks very much, Pierluigi. The same questions from Patrick Magawanya is about the difference, distinguish between the resilience and the reliability of the power systems. It seems to him this mean the same, but obviously you have already clarified that in early answers. Is it, Pierluigi?
Yeah, I think we already gave an answer to that one.
Yeah. So the next question is from Dr. Lai Chunxian, and he's about the PMU standards. So what his question is about, how should PMU standards be shaped to address the current deficiency of the standards? So the PMU standards. Have you any additions?
Okay, yeah. So the main deficiency in the standard at the moment is that there are two ways in which we can conduct measurements. We can use a representationalist approach, which is that we are trying to describe mathematically something about the physical world. So obviously the mathematical model will represent that physical quantity. But the issue that arises is that for the most part, phasers don't exist. Phasers are something that we use our mental model of the world to create that as a mental image to help us understand the world. And that isn't a representationalist measurement anymore. That becomes an operationalist measurement where basically the sequence of events that we do to create the phaser are what is important about the measurement. So this is an extremely superficial differentiation between representationalism and operationalism in measurements. But broadly speaking, that's kind of the issue. So how should the standard change? The standard should adjust itself to reflect the fact that a phaser measurement unit is an operationalist device. One of the examples that's often given is that metal hardness is an operationalist measurement where, essentially you get a spike of known diameter and hit it with a known force, and how far the metal is dented is how hard the metal is. Basically, that's a recipe that you follow to determine the hardness of a metal. A phaser measurement unit is following a recipe to produce a phaser. So there is an ongoing debate within the standards community for PMUs on this very topic. I would like to say that the operationalist side of the debate is gaining traction, but if we are, it is a slow and uphill battle. And certainly if that's something that you're interested in, I would very much encourage you to get involved with the standards committees on that.
Well, thanks so much, David. And now the next question is from Hassan Masru. And his question is about the share your experience of real case studies on microgrid effectiveness on power outage. I think our guest speakers have touched those case studies. Maybe can I ask Nikos and Pierluigi, maybe you could add something additional about the real case studies?
I can add some information. There have been several events that speak about how microgrids have helped maintaining the reliability of the supply of customers in case of large events like disasters. Perhaps the most well-known event is the great earthquake in Japan in 2011, when the Sendai microgrid provided the load for the critical infrastructures, while the rest of the larger utility was for 3 days in blackout. And also there have been events that microgrids have been used in planned outages. So for instance, there is a microgrid called Boredo Springs of San Diego Gas and Electricity Company in US. They wanted to have a maintenance of some major transmission lines, and instead of interrupting the supply for 3 days, they just did it for 10 minutes. So that's two published examples how microgrids have helped in increasing the reliability. And there have been other events, especially for disasters, for resilience. I remember also in New York, this also has happened, where microgrids have helped in improving the reliability to the customer.
Thanks very much, Nikos. Pierluigi, do you have any additional case?
No, I think Nikos was
right.
complete.
Yeah. No, I'm cautious of time because we have another session to start at past 10 here UK time. But we have a few questions. Maybe I'd like to invite the speaker to summarize your thoughts. One of the questions from Wen Chen. And Chen Wen is about the, it's direct to Pierluigi, about the trade-off between the affordability and the reliability, how this could be quantified, and that, for example, are there any commonly used method to calculate the changes in the cost of certain microgrid system if we want to reduce the frequency of power cuts from twice to a week to once a week and so on. So those are the the trade-offs from affordability and reliability. And then Fei Tan from Imperial, his questions about the resilience, given resilience definition for resilience, wondering whether this probabilistic assessment framework was still needed, or whether this probability of events still matter, given the definition of resilience mentioned in Pierluigi's presentation. And and also the last questions from Shihab Degan is about the consumers' willingness to pay. So again, the rural areas is a lot of issues about the cost. In some of these global change funds that we carried, as well as I believe Pierluigi, you are involved as well with Manchester. So can I invite you the speakers to maybe just give your thoughts on any of the questions raised?
Maybe I can just start from the last one.
Yeah.
Just saying that I mean there is no. The answer is very simple. I mean, it's not that it's sort of compulsory to develop microgrids, right? If it makes sense to do it and it makes sense economically, then it should be done. Otherwise, not. So, if the challenge of developing microgrids in rural areas in this case is the economics, well, then it doesn't happen. But it's case specific because in many cases it does actually make sense. So that is the importance of analyzing case by case. I would not generalize. So it's really case specific, I would say.
Yes, indeed. Maybe you could follow on to answer the question from Faye as well from Pierluigi, Faye 10 about the resilience trailer.
Yeah, there are lots of debates about it. I mean, this is about the decision-making technique to deal with that. It is, I think, from a sort of theoretical perspective, it's interesting to understand the issue of low probabilities and how you actually develop security and resilience concepts around that, and there may be of practical interest for conceptualization. However, when you go actually into practical implementation, I agree that it may actually be challenging to assign probabilities to these extreme events, also because there is lots of uncertainty in the rare events, in the fat tails, basically, of the probability when it goes to with these considerations. So effectively, it may be better to start adopting decision-making techniques that are probability agnostic, like more sort of based on risk aversion or that, than probability-based. But I think this is very much an ongoing debate. I think probably over the next few years, we will know more and more about this.
Yes, indeed. And Nikos, do you have any thought to add on it?
I would just I agree with Faye's remark. I think if something is probable, then it's not a resilient event anymore. It's more a reliability event. So really, we speak about low probability events that we don't expect. So in that case, probability of events is not really important. What's of course important is to take into account the probabilities of how the event will develop. That's a different question. I think speak about if we should take probabilities to build a resilient system, and that's I think not something we should do for resilient systems.
Thanks very much, Nikos, sharing your thoughts. And maybe finally, David, do you have anything to add on it? Any thoughts to add, David?
Yeah, no, I agree entirely with the rest of the panel. Just one final thought on this very interesting comment about microgrids in rural areas and consumers' willingness to pay. Yeah, this whole aspect of fairness in terms of microgrids is one which we're already seeing becoming manifest. Because so many of the technologies that are discussed, such as electric vehicles participating in markets and people's PV systems, it's all very nice from a suburban point of view, where I guess many of us academics live. Definitely not something that rapidly translates to social housing and particular apartment blocks. So the issue of who is actually paying to create the sustainable microgrids and who is benefiting from it very much needs to be taken into consideration.
Great. Well, thanks very much, David. I think that's probably brings the closure of the first session, the panel session towards the resilience, flexibility, and sustainability remote microgrids. And I'd like to thank the three speakers again, Professor Hatziargyriou and Professor Pierluigi as well as Dr. David Laverty as well. And so I really I'm thankful to all to all of you for presenting this fabulous the work you have shared with us. And unfortunately, during this current situation, we cannot invite you over to Leeds, but hopefully in the future we'll invite see you all here in Leeds in the UK, and hopefully I'll see you again. Thanks very much. And also I would like to thank the audience for your participation and for of this first session. So the next session we will start at